Here we have an ester to name. So esters, they do have a bit of a trickier name and they do have a bit of a trickier structure, but they're actually pretty straightforward once you practice them a bit. So here we have propyl pentanoate. Important thing to remember is that propyl group is not a branch. What the propyl group is this is the alcohol derivative. So originally, this would have been propanol, and it will have one oxygen bonded to it. Then the pentanoate would originally have been the acid. So this would have been pentanoic acid, and it has two oxygens bonded to it. First part of the name always has one oxygen bonded to it. Second part of the name always has two oxygens bonded to it. So the core structure of any ester is the COO. All esters have this. We have an oxygen and another oxygen. The carbon here, and it's really important you remember there's already a carbon here. The carbon here is bonded to two oxygens. We're also going to have another carbon right here that's bonded to one oxygen. This is how we're able to name and draw these compounds. So my one oxygen alcohol derivative is propyl. Propyl, of course, means that we have three carbons in total. So I have 1, 2, 3 on this side. Then pentanoate, that's my two oxygen side. That means it has 5 carbons in it. So we have 1, 2, 3, 4, 5. And that's how we would draw propyl pentanoate. We have 5 carbons on the 2 oxygen side and 3 carbons on the 1 oxygen side, originally created from propanol and pentanoic acid. Now, there is absolutely nothing that says that you have to draw it this way around. You could also draw it this way, where you have the oxygens facing the other direction. 1, 2, 3, 4, 5, and then 1, 2, 3. That would be, it's a rough and quick sketch, but that would be just as valid a way to draw it. Just draw it a bit nicer than I did there. Here we have an ester that we need to name. So first thing we've got to do when we identify these is we have our 2 carbon side and we have our 1 carbon side. 2 oxygen side and 1 oxygen side. So on the 1 oxygen side, we actually see we only have a single carbon. So that would start this name with methyl. And remember, when you write this name, this time you need a space because this isn't a methyl branch, it's the methyl alcohol derivative, which would have been derived from methanol. Then on our 2 oxygen side, we have 1, 2, 3, 4. So that would give us then methyl butanoate. And that's its name. If there's branches on it, you can stick the branches in it as well, but most of the time when you have to name these compounds, it's pretty straightforward. If we want to know what it came from, because diploma will ask that too, we have methanol and butanoic acid. Also, if you're remembering how you name your acids, what does 8 become when we turn it into an acid's name? It becomes ic, right? you have your ate and your ick suffixes showing up again. So that's an easy way to remember which one is coming from the acid, because it's actually named very similarly to what the acid's name would be if we were just naming it as a solid compound. Okay, final thing we want to watch out for is we want to be able to identify esters. This is the ester group here, because we have two oxygens bonded to the same carbon and then a branch coming off of one of those oxygens. Don't let it get confused for your acid groups, like this one here that I just drew in, and don't let it get confused with your ester groups. We haven't dealt with esters at all, and you don't have to be able to name them, but sometimes diploma questions will ask you to identify where the ester groups are, but this is an ether group here. So that ether group is just one oxygen acting as a bridge within the molecule. And then you do have a double bonded oxygen, but it's further down. It's away from that ether motif. So it's not actually combining the two of them together to create the full ester.